Let's look at another piece of data. So again, here we have the three subcorpora, and we're looking at the distribution of the word thing. And here it seems like the White House, the distribution of thing is quite low. They're using more specific words, perhaps. It seems to be a third of the size of this. So this seems like quite a reasonable difference. But what about this difference here? So we look at the relative frequency, or the normalized frequency per thousand words, and it's very, very close. And so we think, well, maybe my case in meetings has a similar use of the word thing in terms of its frequency of occurrence. But perhaps because we've compressed the data in a way to sort of think about per thousand words, is that really an anomaly by looking at that particular level of relative frequency? And so if we look at the raw frequency here, we have 2,500 in 1.7 million, and here we have 1,500 in a million. So we want to know, well, looking at this data, is there a difference in the frequency of use of thing? This part suggests that there isn't, but I'm just worrying that because we've done this relative frequency, we've kind of hidden, in a way, an actual difference in the data. So what we want to know is we want to have kind of null hypothesis that says the distribution of occurrence of thing in these two subcorpora is the same, and then we're going to use some statistics to test that hypothesis to see whether it's true or false. So let's go to the R, and I'm going to put in that data, just those four scores, just to remind you. So we have the frequency of thing, we're going to call this T1. In my case, the frequency of thing, T2. In meetings, total size of the corpus. In my case, total size of the meetings corpus, that's N1 and N2. So we're just going to work with those four figures. There's not really much else you can work with, some kind of combination of that data. So again, I'm going to type in these values. So the thing in my case, and then we have second value for thing, and then the total number of words. And so this is going to give us our four values which we want to examine. And then in order to do that, we're going to try a proportions test. So here's a proportions test, and it takes as its input one set of values, which is the two frequency values for thing, the two corpora. The second thing is the two total corpus size values. And here we're sort of saying, well, what kind of test is this? It's two-sided. That means we have no expectation that one is the norm and the other. We want to see if there's difference in the second corpus. We're just kind of comparing the two corpora. This is not that we expect a kind of deviation of one corpus from the other. It's not a one-sided test. It's a two-sided test. And this value here, this parameter here, is for a correction, a Yates correction. And so if you have low values, you set this correction to true, and just make sure that test a little bit more conservative. And so I have an error here. Let me try and correct that. I think we want these to be single quotes. Very sensitive syntax. And so if you just look at the bottom, so here's the kind of relative frequency which you might have been working um, with your corpora. Percentage confidence interval, so this sort of says, well, our range of data should be between these rather large ranges, so a very large range there. And here is given as a chi-squared result, 1 degree of freedom. So here's the p-value. So our hypothesis was there was no difference between the two corpora, and that hypothesis has more or less been confirmed by the data. That is, it seems to be a very high p-value, so we're quite confident in our prediction that, yeah, these two the distribution of the frequency of the thing in the two subcorpora is essentially the same. I mean, there's a little bit of variation, but it's essentially the same. We haven't found any significant difference between the two. So this gives some a weight to our initial impression when we looked at the relative frequency.